Thanks for joining me. We're going to talk about congruence and transformations today. Two things that we have talked about before. Transformations was while we were in school, and congruence was the lesson I had you look at the week before spring break. So get your note page ready. It should have the title on there. And by the end of today's lesson, you should again be able to define congruence and see if you can use a series of transformations to create congruent shapes. Just a quick review. What is congruence? There's a word in there, in the word congruence, that we use a lot in math class, congruent, and we know that that means equal. So if two figures are congruent, their corresponding sides are congruent and their corresponding angles are congruent. So that means sides from one shape to the other that match up in the same place, those are corresponding sides, and angles from one shape to another that are in the same place are corresponding angles. When I had you look at congruence a couple weeks ago, we looked at these triangles and kind of talked about, okay, side AC has 3 tick marks, side DF has 3 tick marks. So AC is congruent to side DF. And remember, the symbol for congruent is that little wavy line over the equal sign, or you can just write out the words is congruent to as well, if you can't figure out how to make that symbol on your computer in your notes. Angles with the same tick marks are then also congruent angles. Okay, and we looked at this triangle, these triangles in detail in those notes we took a couple weeks ago. So that's congruence. So now, how do I determine if two figures are congruent by using transformations? So I have 2 triangles here, and possibly some transformations occurred to make a triangle ABC into triangle ZYX. Okay, and we have to use what we know about transformations to see if this was possible. So the first thing that looks like might have happened to triangle ABC is it looks like it might have kind of turned itself over, and which transformation is kind of like turning itself over? A reflection, yeah. So if we can imagine that maybe there's the y-axis here, and what happened is ABC reflected over that y-axis. So side AB that was on the left is now on the right. A reflection could have occurred. So that could be true. But if a reflection occurred, this is what it would look like, right? We need it to look like this blue triangle down here. So how could A prime, B prime, C prime get to where ZYX is? What transformation lets a shape kind of slide across the coordinate plane? If you said a translation, you are correct. So you could then take that pre-image A prime, B prime, C prime and translate it down and to the left. We don't know how many places because we're not actually on a coordinate grid, but down and to the left, and then it will match perfectly onto triangle ZYX. So you could say these triangles are congruent because a reflection followed by a translation occurred. And these occurred to then create the new triangle ZYX. Okay, let's look at another case. Now, if any of you are fans of the game Tetris, this totally reminds me of a Tetris piece. I grew up playing Tetris, and it's big again now. My son Zachary likes to play it on the Switch, I believe, downstairs. So again, I have 2 figures. Can I determine if they are congruent? Did some transformations occur to make these congruent? So the red is my original, and green is where I'm going. All right, well, if I look at it initially, I'm going to say again, it looks like it kind of maybe flipped over to start. So what transformation kind of has that flip over where it's looking in a mirror? I would say a reflection. So it started out, maybe there was a reflection over the y-axis, creating the pre-image of the red Tetris piece, okay? But with that reflection, so now I have it facing the same way as the green one, if you kind of look at the two pieces, you're going to notice something. On the red one, on the original, when you go 2 up, that's where you have the extra part come out. But on the green one, if you go 2 up, there's no extra part coming out. It happens at 3 up. So if you wanted to say a translation occurred, that doesn't work, because when you translate it up, the pieces aren't going to match. Where C comes out is not where D is. It would actually be a piece below. So this does not match exactly. The translation didn't work this time. We could reflect it, but we could see in that reflection that it wasn't then going to match up with the new green Tetris piece because of where that part comes out on. So this time, they're not congruent because a reflection followed by a translation did not create two congruent figures. So the goal of this is you're going to look at two shapes and decide, did some transformations occur to move this shape into the position of the second shape? Are they still congruent? They have to still be congruent. That's the key there, okay? First example, triangles were. You could reflect and translate. Second example, the Tetris pieces, it wasn't, because after the reflection, you couldn't translate to match up to the green. They were not the same piece. So let's see if this makes sense. Go ahead and complete your notes, turn those in, and I'll get back to you soon. Thanks for tuning in.